Hello students, a warm welcome to you all for the session 5 of JEE Advanced 2023 preparation in chemistry. As I have been insisting from the beginning that chemistry happens to be the best scoring subject for JEE Advanced. In pursuit of that, I am trying to give you my best in the form of the solutions and thus the discussion related to the concepts of fundamentals by using the PYQs. So we have seen over the last 4 sessions that the chapters like stoichiometry, I mean to say the critical chapters or tough chapters such as stoichiometry and equilibrium had also been covered along with the thermodynamics. Now we have entered into the session 5 where the chapters which are covered here comprehensively through the numerical solving are the chemical kinetics, surface chemistry and electrochemistry. As you know that these are the most important chapters of the physical chemistry from which the questions are fused and asked together. So in today's session we are going to solve at around 10 to 15 or 20 questions maximum to learn the concepts which are involved in these chapters, which are frequently or repeatedly asked in the JEE advanced examination as well. So let's start, let's see these questions. So to give you a kind of comfort, I would like to first discuss the questions from surface chemistry. As we all know that the questions from surface chemistry are little bit straight or theory oriented, so you can save much of your time by solving the question from this chapter. If you are thorough in the fundamentals of this chapter, you can study the NCERT textbook to understand the concepts better here. Need not refer to any high standard textbook, rather you stick to the NCERT textbook and solve the questions which are given at the backside pages of NCERT, and for practice take any practice book and solve the question, and especially don't forget to solve the previous year questions, so PYQs, right? So you can see the first question is theoretical, as I had been saying that the question is about adsorption. The chemisorption results in unimolecular layer, isn't it? We know that chemisorption is specific and it is forming a unimolecular layer, unlike the physisorption. You can see that physisorption is multi-layered. I have given you the reference table here also. But whereas the chemisorption, because a strong chemical bond is being formed which will not let the other layer to accumulate on it, right? Like you are writing say some script on the white paper and you are just able to shade it or just able to darken it, but you are not able to interpret another information on the same the document, isn't it? So it is single layer reaction or the process that takes place in the chemisorption, right? And the enthalpy change during physisorption is in the range of 100 to 140. You know that physisorption is involving the van der Waals forces, hence the energy that is released in that particular process will not be so high. It will be somewhere between 20 to 40 kilojoule per mole. So it is not correct to say that physisorption is of the order of 100 to 140. It's actually near to the chemisorption value, because the bonds in chemisorption are stronger than that of physisorption, isn't it? So this statement is incorrect. All right. Now you know whether it is physisorption or chemisorption, it is basically heat releasing, because the new bonds are formed on the surface. Now, when new bond is formed, definitely the energy is released but not gained. It is exo but not endo. Lowering the temperature favors physisorption. Yes, when you are applying the temperature here, the gas tends to elope. So when you decrease the temperature, the gas tends to sit on the surface. Therefore, this is the correct statement. As you know, as you can see, the parameters that are related to the physisorption and chemisorption are being mentioned and distinguished between these two adsorption process, right? So I want you to go through the table also for the reference purpose. So this is easy question for which the answers are A and D. All right. Let's see the next theoretical question. Again, theoretical question. Adsorption is accompanied by the decrease in enthalpy. That is, you know that adsorption leads to the formation of the bond and heat is released, and decrease in entropy, as we all know that the randomness is decreased when the gas or is sitting on the surface. The randomness is decreased, so entropy also decreases. It makes sense. The second statement, The critical temperature of ethane is 563 and that of nitrogen is 126 respectively. The adsorption of the ethane will be more than that of nitrogen. You can see that we have studied in liquefaction of the gases, right? Critical temperature actually comes in the gaseous state. As we all know that more the critical temperature, easier is the liquefaction of the gas, isn't it? Of the gas. That means maybe that gas has the polar forces. As we could see that when you are comparing here ethane and nitrogen by virtue of their critical temperature, you can see that ethane and N2 are being compared. The critical temperature here is 563 and here is 126. That of ethane is more. Therefore, the adsorption of the ethane is greater because it can be easily liquefied, as we know that the adsorption or rate of adsorption is higher for easily liquefiable gas. Therefore, option B seems to be correct only. Cloud is an emulsion. Okay, so this is a wrong statement that cloud is a colloid, right? So this is wrong. Brownian motion of colloidal particle does not depend upon the size. It is wrong, right? As we know that the Brownian movement is all about the interaction between the light particle with the colloidal particle, and you know that it is directly proportional to the Brownian motion. Is directly proportional to the size of the particle, but depends upon the viscosity. Of course, when the viscosity increases, the Brownian motion decreases because the solution or the medium has become the viscous. It will not let the light particle to move freely. So right answer for this question is A and B. Hope you understood. Let's move on further. Another question from the surface chemistry, again theoretical question. The process of precipitating colloidal solved by an electrolyte is called peptidization. Precipitation and coagulation are the linear terms in surface chemistry. So it is not peptidization, isn't it? We have studied in the boards, right? It is called coagulation. So option A is wrong. Colloidal solution freezes at higher temperature than the true solution at same concentration, right? You know that if you take the colloidal solution, I will be writing here that colloidal solution has more mass than the true solution. We study this as the basic property distinction between the colloid and true solution, and we know that colligative property is inversely proportional to the molar mass, isn't it? Isn't it? It's directly proportional to moles, hence inversely proportional to molar mass. Therefore, we can say that the colligative property of the colloidal particles is less than that of colligative property of the true particles. Okay, that means here the delta TF is being mentioned. Delta TF, colloidal, one of the colligative property of the colloidal solution is less than that of delta TF of the true solution. So when you are writing delta TF, you know that you will be writing TF naught minus TF, depression of freezing point of the colloidal solution is less than that of TF naught minus TF of the true solution. As you can see that this value being constant, when I say that this difference is greater, isn't it? When this difference is greater, that means the TF, this implies what? The TF of the true solution is greater than TF of the colloidal solution, isn't it? So colloidal solution freezes at a higher temperature than true solution at the same concentration. You can see that the freezing point of the colloidal solution is greater. So this option looks to be okay. So surfactants from form missile above critical missile concentration, and CMC depends upon the temperature. That's called Kraft temperature. It's a theoretical question. I have given you some information related to the critical missile concentration and Kraft temperature. I want you to go through this theory. It is useful. As you can see that missiles can be formed only when the concentration of the surfactant, which is actually responsible, isn't it? Surfactant actually responsible for the formation of the missile the concentration of the surfactant is more than that of the CMC value. Alright, then only the micelle formation effectively takes place, and it depends upon the temperature and other factors are also mentioned, right? So surfactant form the micelle above the CMC, and CMC depends upon the temperature. Correct statement. Micelles are macromolecular colloids. No, they are not macromolecular, rather they are associative colloids. You know how micelle is formed. It's not one molecule, it is many components are clubbed together to give you the associative unit, but not macromolecular. Macro means one unit, bigger unit. Associative means smaller unit, composite unit, isn't it? Another theoretical question, right? Here they tried to combine the surface chemistry with the electrochemistry. Now you can see the molar conductance of an aqueous solution of sodium stearate, that is C17H35 COONA, as we could see that this has the two components, that is hydrocarbon part and the carboxylate part. You know that this is hydrophobic because it has non-polar component, it doesn't like water, and this is polar, which is called hydrophilic. So can comfortably form the micelle, right? As we could see that it is relation with the lambda versus concentration, as you can see that which behaves like a strong electrolyte, it required at varying concentration of sodium stearate. Obviously, which of the following plot provides the correct information of the micelle formation in the solution? You can see that over here at critical micelle concentration, you know that the micelle formation will start happening like we have seen in the last question. That means this leads to the formation of the associative colloids. That means the number of ionic parts decreases and this lambda value further decreases abruptly. You can see that here it is decreasing and remaining constant, decreasing and then increasing, increasing, and there is no point that it will increase, right, or remain constant. It will drastically fall down because here the movement of the particles is further frozen because of the formation of the micelle. So this is the right answer for the question. It keeps on decreasing, but it decreases rapidly after the CMC. It's a beautiful question asked combining the electrochemistry as well as the surface chemistry. Easy one, isn't it? Now you can see there are few questions related to the electrochemistry which are based on the electrode potential values. You can see that two species are given, X plus 2 and Y plus 2, with their concentration, and you need to put these species in the substitution for X and Y. You have to pick what are X and Y respectively depending upon their potential as well as the concentration ratios that we are going to do by using the Nernst equation, isn't it? Now we can see that they resulted in the dissolution of X. So you need to understand the core of the reaction. X is getting dissolved. X has to get dissolved in the form of, you can see all are bivalent ions. So here Y plus 2 is oxidizing it so that X can get oxidized or X dissolves and this thing. So what is happening on the whole, that this is undergoing oxidation, that means its oxidation potential value is high, isn't it, or reduction potential value is low. Or you can say that this is undergoing reduction, that means reduction potential is high, oxidation potential is low. However, it doesn't depend upon these two values, I mean E0 values alone, it depends also upon the concentration. So we need to say how the combination has to be framed in such a way that this cell can function spontaneously. For that I would apply the Nernst equation, EMF equal to E0 of the cell minus 0.06 by the electrons which are involved in the process. For any species it appears to be 2 log of concentration of X plus 2, as you could see, that is 10 to the power minus 3 divided by concentration of Y plus 2, as you can see it is 0.1. So this value is turning out to be E0 minus 0.03, this is 10 power minus 2, and this will become minus of this minus plus, and this 2 gets cancelled and log 1, isn't it, right? So this is 10 power minus 2 and this minus will become cancelled and this 2 gets cancelled over here, isn't it? Am I right? And log 10 is 1. So this is 0.06. So this is the net equation that we are getting out here. Understood? Now after getting this, we need to substitute the ions with respect to their reduction potential values. As you know that all of them are having the negative values of the reduction potential. Since I know the answer, I can upfront substitute here and check which one is the right answer, isn't it? Right? So what you're going to do is you're going to substitute the values here so that the E can be, the point is what? E can be positive, then only the dissolution delta G equal to what? Minus NFE. When this is positive, then only this value will be delta G will be negative. That means dissolution will be spontaneous. That is the agenda here, isn't it? So the E value is turning out to be, you have to substitute the E naught. You can see that X and Y respectively are. So you have to pick the species properly. Since I know the answer, I am picking it up and I am trying to explain you. Like you can see that X is getting oxidized. Reduction potential of cathode. Cathode is Y plus 2. So Y is lead, isn't it? Reduction potential of cathode minus of reduction potential of anode. Anode is nothing but nickel plus 0.06. So this E value is turning out to be minus 0.13 plus 0.24 plus 0.06. That means on the whole this value is turning out to be positive. For all the other species you have to check. I am not sure about this. I want you to check. Since I got this as the answer, I am putting it as the answer, isn't it? You have to check whether E value is positive or not. That's how we are going to solve the question. Now let's see the next question, which is combining the electrochemistry with the ionic equilibrium. That means the dissociation of monobasic acid. The limiting conductivity means what? The lambda naught, that is the conductance at infinite dilution. At 298 Kelvin, the aqueous solution of acid, the degree of dissociation is alpha. And the molar conductance of this value is Y into 10 power minus 2. So what I am going to do is, you know, for a weak acid dissociation HA, H plus and A minus, at a particular concentration you will write it as C into 1 minus alpha C alpha C alpha, where the conductance of the solution is lambda. And at infinite dilution, when this becomes C and C, it is called limiting molar conductance lambda naught. As we know that lambda is directly proportional to C into alpha, concentration of ions, and lambda naught is directly proportional to C. You will get the value of alpha as lambda upon lambda naught. Now we can see the values are given to us. We are given the conductance and the limiting conductance. So alpha value is turning out to be for us the lambda, that is Y into 10 power 2 divided by 4 into 10 power 2. So we got the value of, isn't it, alpha as Y by 4. We have to get the answer in a numerical value. We got in terms of the Y. To get it in numerical values, what I am going to do is to take the next information. You can see that at 298 Kelvin, upon 20 time dilution with water, the molar conductivity of the solution becomes 3Y into 10 power 2. So this is the whole process. I am taking it as alpha 1. I will call this as alpha 1, that is before dilution. So what is happening here after dilution, one should understand. After dilution, you know that alpha increases and alpha 2 will become what? I will call this as alpha 1, and alpha 2 will become lambda by lambda naught, that is 3y into 10 power 2 divided by 4 into 10 power 2. So alpha 2 is turning out to be how much? 3y upon 4. So this is alpha 2. Alright, for this weak acid dissociation, please understand. For the weak acid dissociation, you know that alpha is equal to under root of Ka upon C, or you will write the value of Ka equal to C alpha square. You know that Ka is constant, isn't it? The value of Ka is what? Constant. Acid dissociation constant, no? So what will happen here, that when Ka is constant, upon dilution it doesn't get affected, C1 alpha 1 square equal to C2 alpha 2 square, because you know that C1 and C2 are the concentration of the solution before dilution and after dilution, right? This is what? Before dilution, and this is after dilution. Since we have assumed the initial concentration as C, as you could see that the alpha 1 value is y by 4 whole square, concentration of the solution after dilution will become what? 20 times less than the initial value into alpha 2, that is 3y by 4 whole square, isn't it? Now we got the values of the you have to substitute for alpha value, you have to substitute, of course you cannot take this into consideration, right? ఇక్కడ వరకు ఆపేయండి, మళ్ళీ ఒకసారి రికార్డ్ చేస్తాం, దాన్ని కంటిన్యూ చేద్దాం, అక్కడ నుంచి దీనికి మర్జ్ చేసేద్దాం. ఓకే, so let's see the next question, that is you can see that at 298 Kelvin the limiting molar conductivity of a weak monobasic acid is given, that is the value of limiting molar conductivity means lambda naught, and you can see that the molar conductivity is given as the lambda. These two values one must know, and alpha degree of dissociation. You know how to connect the values, isn't it? For a weak acid dissociation, as you know, the concentration at equilibrium I will assume as C into 1 minus alpha, where alpha is degree of dissociation, and at infinite dilution at the limiting value you can see that it is C and C, that is conductance is lambda and this is lambda naught. As we know that alpha, the degree of dissociation is lambda upon lambda naught, isn't it? Therefore, from the given values, like you can see that lambda value is y into 10 power 2 and lambda naught value is how much? 4 into 10 power 2. So, this value is turning out to be how much? Y upon 4. This is before dilution. The every situation over here is before dilution. Now, you can see after dilution what will happen? The alpha value, degree of dissociation increases according to Oswald theory. Oswald dilution theory, isn't it? Now, what's happening here, that the alpha value, I'll call this as alpha dash, is equal to, you can see that lambda value is 3y into 10 power 2 divided by lambda not remain constant, isn't it? 4 into 10 power 2. So, alpha dash is equal to 3y by 4. So, you can see that y by 4 is alpha, that is 3 times of alpha. As you know, for weak acid dissociation, the value of K equal to C alpha into C alpha upon C into 1 minus alpha, isn't it? Therefore, you can see that C gets cancelled and K equal to C alpha square upon 1 minus alpha, isn't it? Now, you can see that you can neglect alpha compared to 1, assuming alpha is very much less than 1, I will write 1 minus alpha is equal to 1. So, you can see that K equal to C alpha square, or even you can take that whole equation and you can simplify that, right? So, using this expression, like you know, Ka values are nowhere mentioned, isn't it? Therefore, you can see that using this expression, okay, let us not neglect this, let us express the whole values of alpha because we never know whether that is negligible or not. So let us not take this condition. We will take this condition if the calculations are getting more and more complex. So like you can see that Ka value, which is constant for the initial concentration, C alpha square by 1 minus alpha. This is before dilution case. This is what? Before dilution. That means we haven't diluted yet. And after dilution also Ka remains constant. The concentration becomes what? C upon 20, because you have diluted it by 20 times. The concentration decreases by 20 times into alpha. Now we can see the alpha dash will come into picture, that is 3 alpha whole square upon 1 minus alpha dash, that is 3 alpha, and these two values are equal. Now we can see you have to get the value of alpha. I think you must have understood by now why I did not neglect alpha in comparison to 1. You can see that it has increased 3 folds initially compared to. So you can neglect here, but you cannot neglect here. So that is the reason why I kept it intact. You have to solve for what? Alpha. Okay. So you have to find the value of alpha. I hope you understood, right? Easy question, but little bit of calculation is involved. Now let's check the next question. Is similar to this question, as you could see that there is a concentration of particular electrolyte which is given. You have to interpret the data while solving these questions. A lot of questions are on the conductance, you can see, right? So don't ignore that part: conductance, specific conductance, molar conductance, etc. Like you can see, distance between the electrode, that is nothing but L, with cross sectional area, that is A. What are all values are given? The conductance of the solution was found to be this. pH of the solution is given, alright, because it is weak mono basic acid. So let's solve the question in the same manner that we did in the last one. You can see the question, there is similarity between the question. The value of limiting conductance, that is lambda naught of weak, is Z into something, and you have to find out this value, isn't it? So you can see that when I write that again, alpha equal to what? Lambda upon lambda naught. As you could see that the value of limiting conductivity is expressed in terms of what you call lambda naught, that Z, that is. So if you want to find this value, you need to find out these two values, isn't it? Alright. As you could see, for the weak acid, I'll finish each task one by one. H plus into A minus, H plus A minus. For this concentration of the solution, that is 0.0015, the degree of dissociation is alpha. As you can see, 0.0015 alpha. This is 0.0015 alpha. Now it is given that pH equal to 4. That means negative log of H plus value is given. So concentration of H plus, which is over here, is 10 to the power minus 4, isn't it? That is 0.0015 alpha. Therefore alpha value equal to 10 to the power minus 4 upon 0.0015. So you got the value of alpha. One task is finished. You have to get alpha first. You got the alpha, because I told you to cater that equation, you need to get alpha and the lambda. So to find the value of lambda, we all know the expression, right? You can see that the conductance of the solution is given, as we all know, that C is equal to K into A by L. Alright, so conductance is given to us, isn't it? Now C is equal to K into area of cross section by length of the medium. Now we know conductance value is given to us. The conductance value, where is it? Yeah, 5 into 10 power minus 7 equal to the conductivity, that is specific conductance, into A, the cross sectional area is given as 1, and the distance is 120. So you got the value of conductivity, 120 into 5 into 10 to the power minus 7. As we all know that the conductance equal to 1000 into K upon the concentration. When you substitute the values here, 1000 into 120 into 5 into 10 to the power minus 7 upon the concentration of, this is not conductance, this is concentration, right? 0.0015. So you got the value of the lambda as well as you got the value of alpha. So you need to substitute these two values in the given expression so that you can get your answer, isn't it? So substitute these two values in this expression, so you will get alpha. It's not conceptual, it is more like theoretical question, including little bit of numericals by using some formulae. Like this is the question which I have seen in the recent times, the easier one, just like JEE main, like there is an upfront Daniel cell equation is given, and you can see the concentration of the M plus 2 is 10 times that of Cu plus 2, and expression for delta G naught is asked. As we all know that EMF of the cell is E naught of the cell, that is 1.1 minus 0.0, that is RT by NF. Rather you should write it as what, RT by, because you have to express that in terms of RT. And it is 2F because number of electrons are involved 2. Natural logarithm of concentration of, as you write the cell reaction, you know that zinc gets oxidized and copper gets reduced, the Daniel cell, isn't it? So when you are writing here the overall equation, you will find that zinc is replacing copper plus 2 from the solution. So when you write the expression, you know concentration of Zm plus 2 by concentration of Cu plus 2. Rest of the two components are solid, so you need not take its concentration. They are regarded as 1. So EMF equal to 1.1 minus RT by 2F. As you can see in the question that the value of concentration of Zm plus 2 is 10 times that of concentration of Cu plus 2, isn't it? Alright, so Cu plus 2 gone, okay. E equal to 1.1 minus RT by 2F into 2.303 log 10. So you got the value of E, isn't it? 1.1 minus RT by 2F into 2.303. And we have to express the value of the delta G naught. As we all know, delta G is equal to minus NFE. And just you need to substitute the values. Minus N is to F into the whole EMF value need to be substituted, isn't it? So there you will get the answer to the question. Alright, so this is a straight question asked simply in the recent time, right? The questions are actually lengthy in IIT to solve, but that question was a little bit easier. Now you can see another lengthy question. This has nothing less than the calculation. This has mostly calculation part involved than the conceptual part, because electrochemistry is either Faraday's laws based, Nernst equation based, or simple Kohlrausch law based, and one of such question is related to the Kohlrausch law, because you can see that this is also electrochemistry question, and mostly it is based on the Gibbs-Duhem equation or the Kohlrausch equation. Kohlrausch equation is very frequently asked in the JEE advanced as well as JEE mains, right? So let's see this question and let's try to understand how it can be interpreted. You can see that limiting molar conductivity is given for UMYP as m times of lambda naught of U. I'm not going to write the whole thing, right? It's a wastage of time. Plus P times of lambda naught of Y. So this value is given as 250. Likewise, you can see lambda naught of Vm xn is given, which is equal to m times of lambda naught of V plus n times of lambda naught of x, whose value is given to you as 440. Now let's take these two equations into account, and these values are anyways given, right? M into lambda naught of U is 25, that is 25m, plus P into lambda naught of Y, which is equal to 100. So this is equal to 250. So this is one expression you have, isn't it? Now you can see that this value is 440. M into lambda naught of what is this? Vm, isn't it, right? So Vn is 100, right? So it is 100 into m plus lambda naught of x, which is given as 80. 80 into n is given as 440. So these are the two equations we have. I am going to write the equation, you are going to solve them, right? These are the two equations which are required, which are there, right, to be used in the coming time. Like you can see that the relationship between the conductance versus the concentration is this, right? Now we can see the values For 339, you have lambda naught minus the constant b into the square root of c value is 0.01, and other value is also given, that is 336, which is equal to lambda naught minus b into 0.04. So you have these equation. I want you to multiply this by 4, okay, so that this gets cancelled and you have to get the lambda naught of what is the substance Zmxn. As we know that lambda naught of Zmxn is equal to m times of lambda naught of z plus n times of lambda naught of x. So you have this value over here, so you substitute here, isn't it? Lambda naught equal to, getting complicated, isn't it? M into lambda naught of z 50 plus n into lambda naught of x, that is 80. So you substitute that whatever lambda naught that you get over here, and this is the third equation. So 3 equations and 3 unknowns, you have to solve for m, n and p. That's all, right? It's all theoretical question using all the concepts beautifully. Now let's see the next question, again from electrochemistry. You can see there is an equation, reaction that is taking place, and dE by dt, that is temperature, coefficient, thermodynamic factors, right, in electrochemistry. Then the entropy change of the reaction is R. Let's see. As we know from thermodynamic laws related to the electrochemistry, minus delta S equal to NF into dou E by dou T at constant pressure. If you have any doubt about this, from where did we get that, I am here to help you in its derivation also, right? As we all know that minus delta S is equal to, I think at least you know this, right, dou delta G by dou T at constant pressure, and we know that delta G equal to minus NFE. Alright, therefore what do you get here, that minus delta S equal to, alright, you can see that NF minus gets cancelled, right, on both the sides. NF dou E by dou T at constant pressure, dE by dt or dou E by dou T, one and the same for small changes. It's called temperature coefficient, isn't it? So your minus got cancelled, right? So delta S equal to N equal to 2, like you can see, number of electrons for the oxidation purpose 2F into this value is given as R by F. So this value is turning out to be 2R, however it is given as R. So this is not a right option. Next question, the cell reaction is given H2, alright. So for option B, you can see the reaction that are taking place. H2 is converting into what? 2H plus, concentration is 10 power minus 2 plus 2 electrons. And in the other process, 2H plus 10 power minus 1 plus 2 electrons giving rise to H2. This is the concentration cell, isn't it? Now when you write the overall equation which is taking place here, you can see 2H plus 10 power minus 1 giving rise to high concentration to low concentration of the electrolyte concentration cell. So what's happening here, that the value of EMF, because E0 is 0, minus 0.06 by 2, or I'll take this as 1 and take the squares of concentration of product 10 power minus 2 divided by concentration of reactant 10 power minus 1. So this value is turning out to be how much? 10 power minus 1 is left out, 0.06. Alright. So is an entropy driven process. You can see that this cell has certain potential, right? If EMF is equal to 0, then we call this as entropy driven process. Alright, so you can see that E is positive, because what's happening here, that high concentration is changing into what? Low concentration of the electrolyte. So what has happened here, entropy decreased and this reaction is taking place. There is nothing wrong in saying so, but the point is it is not entropy driven, it is thermodynamic driven also, right? But it is entropy driven also, but this question is not apt to the given option, but however we can say it so, that it is entropy driven process, because delta G is positive, it is Gibbs free energy driven or energy driven also. It's not only entropy driven, but is and entropy driven means it's one of the option to be considered. So I'll consider B also. For racemization of optically active compound, delta S is entropy increases. Whenever racemization takes place, that means whenever two substances are formed, the racemization right, racemization when takes place, it always accompanied by the increase of entropy, because whenever racemization takes place, one unit converts into 2 units, so entropy is increased. Alright, so delta S is positive, and over here you can see for this reaction H2O, the monodentate ligand is replaced by bidentate ligand. So what is happening in this, complexity is increased. That complex ligands, right, bidentate ligands. So complexity is increasing when the ligand is becoming bidentate. So monodentate to bidentate to tridentate, what will happen to the entropy? Increases. It will become more and more positive. So this is also correct. So right answer for this question is option B, C, D. I am little bit skeptical about the option B, but that's okay. You can see the next question, that it is 3-degree alkyl halide which is undergoing the nucleophilic substitution, as we call it in organic chemistry as SN1. That the order of the reaction equal to 1. So this whole question is about this chemical kinetics question. When order equal to 1, that rate depends upon the concentration of only the alkyl halide. For first order reaction, T half is independent of initial concentration. It is absolutely correct to take A into consideration. However, rate increases linearly with the concentration of the reactant. So this is wrong. And let's see the concentration ratio of P by P naught. Alright, let's check it. It's a first order reaction. So we get natural logarithm of initial concentration is P. So you will write K equal to 1 by T, natural logarithm of initial by final. So natural logarithm of P naught by P is equal to KT. Right, so natural logarithm of P by P naught equal to minus KT. That means you will be getting a straight line with a negative slope. So this is ruled out, right? This is ruled out because here it is given as the positive slope. So we have ruled out so far these two, and let's check this out. Okay. Now how to check it? Let's check this option. As I could write here, right? Now KT, that is, I'll use this equation 1 and write it over here. Q is nothing but the concentration of the product which is formed from the reactant, is nothing but P. Alright, so it is actually, what is Q? Amount of the substance, initial concentration of P, and P, I think the question looks to be incomplete. So what's happening here, that A is giving rise to the product, initial concentration is P naught and final concentration is P. That means the reacted amount is P naught minus P, and which is nothing but the product out here. Alright, so concentration of the product is actually Q. So we have to take this P naught minus P into concentration. Alright, or else I'll consider this as 1 mole of the substance. I'll write this in terms of the degree of dissociation. I'll take this equation first. You can see that I'll get P by P naught equal to E power minus KT. As I could see that when I am writing 1 minus on both the sides, I will be getting degree of dissociation, or the degree of reaction equal to 1 minus E power. This is nothing but, as we could see, that Q by P equal to 1 minus E power minus KT, for which the graph will turn out to be like this, but not like this. So this is also ruled out. Okay. Ruled out? Yes, the right answer for this question is only option A. Very interesting question, isn't it? Let's see the next one. As you could see from this expression, like as you can see, the letters appear to be pretty tiny. You have to match these conditions with these conditions. Now we can see that for all possible initial concentration of X is practically not possible, right? Practically by taking all possible values of x, we cannot take this equation as a reference to solve it. So, we will start it from here because our intention is to solve the equation. You can see that the initial concentration of x are much less than that of xs. Xs is the concentration of the what you call reactant after some time. So, you can see for 2, it is being mentioned that the initial concentration of x are much less than. So, x value is much less than xs. So, from this expression you can see x can be neglected, alright. So, rate equal to k by some constant where the initial concentration of x are much less than xs. So, x value is negligible, isn't it, right? X divided by xs. So, you can see this is first order equation because rate depending upon the concentration of the reactant, which is x. So, first order equation, what is the equation for first order reaction, right? You can see that half life and initial concentration are parallel. So, you can see for 2 the matching option is q. For 2 the matching option is q. So, these two are ruled out. So, we have to pick up from A and C. Let's see. Okay, first time anyways I am not going to do. Let's take the third condition. Anyways, you might get the answer upfront, right? Third condition, you can see where the initial concentration of x are much higher than xs. Third condition is x is much higher than xs. So, xs can be neglected from that expression. So, rate equal to k into x by x. So, you can see xs is neglected. That means it is constant. Alright, that means it is zero order reaction. So, if it is zero order reaction, the rate law or the constant is equal to what? A naught minus AT upon T. So, you will get AT equal to minus K naught into T plus A naught. So, concentration versus time is a straight line with a negative slope. So, you can see third matching is S. So, right option for this question should be A. Based on these two, I have solved this question. You can use the other parameters also if you want, but I do not think so it is required. You have to use the shortcuts at certain times while solving these questions by keeping the constant. This is called isolation method, right? If you want to find out what you call the order of a reaction with respect to any component, you make the other concentration as constant and do it, right? So, as you can see that I am going to keep two values constant at a time so that I can write the rate law predicting the orders of A, B and C respectively. I will assume that the order with respect to A, B, C are X, Y and Z. Now, you can see what I am going to do is I am going to take first and second experiment into consideration. You can see I am keeping A as well as C constant, and you can see that the rate is concentration of B is increased by 2 times and there is no change in the rate. That means the reaction is not depending upon the concentration of B. So, Y equal to 0. Alright. So, we got one answer. This is your first step. Next, second step. Every time I am going to do that, right? So, this time what I am going to do is I am going to keep the first and third constant. What I am going to do is first and third, you can see experiment 1 and experiment 3. As I could see that I am keeping A as well as first and third. Yes, first and third, A and B are constant. Then the concentration of C is increased 2 folds. Then rate increased by 2 folds. That means power is 1. Alright, so C to the power in 1. You got A power x, B power 0 and C to the power 1. Rate 2 times increased means the power is 1. Alright, we got it. Now we need to find the value of x. For that, we are going to keep B and C constant. You will just check 1 and 4, isn't it? Am I right? 1 and 4, you can see 1 and 4, 1 and 4. B and C constant, and when I increased this by 3 by 2 times, 0.2 to 0.3. 1 and 4 data I must check. the rate also increased by 3 by 2 times. 6 to 9 means 3 by 2 times. That means it is also first order with respect to A. So first you need to find the order of the reaction cleverly by using the shortcut, and then you substitute these values by taking any of these values. Rate equal to rate constant. Rate is only asked, no, there is no issue at all, right? When the concentrations are given, the rate is only asked, not rate constant. So you can see you have to find out the rate equal to rate constant. First you have to, okay, it seems that you need to find out first the rate constant from the given values. Okay, yeah, we will do that first. 6 into 10 power minus 5 equal to K into concentration of any, you can take the 0.2 whole power 1, 0.1 whole power 0, that is 0.1 whole power 1. So you have to find K. You know, K remains constant throughout. So after finding out the K, rate is asked, that is Y equal to 10 power minus 5, which is equal to K into concentration of A is 0.15 whole power 1, B is 0.25 whole power 0, C is 0.15 whole power 1. So what you need to do is you have to get the K and substitute it over here so that you can find the value of Y. Only numerical question. A lot of numericals, there is no logic or no so much depth involved in this question, right? Next question is also what you call from the chemical kinetics, discussing very important concept related to it. You can see that the initial pressure is given as 1. Let's assume some X amount of pressure is decomposed after certain time. Alright. You can see that initial pressure is 1 after Y into 10 power 3. That's what I was looking for. You know, at T equal to 0, this is the condition at Y into 10 power 3 second. You can see for 2 moles, you are getting 2 moles of N2O4. For X, you will get X, and this is X by 2. Now it's given in the question that the total pressure inside the cylinder, that is N2O5 plus N2O4 plus O2 put together equal to 1.45. So you can see you got the value of X, 0.9 atm. What that you need to find out here, if the rate constant is this, you have to find what? Okay, time. So you know that this is a first order reaction based on the units of the rate constant mentioned as per second, that you know that mole per liter whole power 1 minus n second inverse is the unit. So you can make out here that n is equal to 1. So for the first order reaction, the rate constant 5 into 10 to the power minus 4 equal to 2.303 divided by time is Y into 10 power 3 log of initial pressure by final pressure is 1 minus 0.9. So you have to find the value of Y. You can see in the next question, very important question, right? You know, 2x plus y giving rise to p. The rate expression is in terms of dp by dt and x. So you have to first of all write it in terms of x, that is minus 1 by 2 dx by dt concentration. I am not writing the square brackets to minimize the time, equal to dp by dt, isn't it? Now you can see that these substances are reacting like this. At T equal to 0, the concentration or the number of moles of X is given as how much? 2, and Y is given as 1. After 50 seconds, the 0.5 is left out. That means 0.5 might have reacted because 1 is the mole that you have taken. 0.5 is left out. 1 mole react with 2 moles. So for 0.5, 1 has reacted. So remaining is also equal to 1. The X remaining is also equal to 1. Therefore, we can make a statement here that for 2 moles of X, 1 mole of X remaining means the half-life period is equal to 50 seconds. Alright. That question is solved, isn't it? Or option B, half-life is 50. Now we can see that minus dx by, because rest of the questions are in terms of dx by dt is equal to, alright, this value is given as k into x. Okay, 2 times of k into concentration of x. Therefore, this constant will become some k dash into x. This is the apparent value, this is the true value, isn't it? Now, when you look at these values, you have to get dx by dt, isn't it? For that, first of all, you have to get the rate constant, and you know that k is equal to, t half is equal to 0.693 by k. Here you need to write the true rate constant, that is equal to 2 times of k. and this is equal to 50. This implies K is equal to 0.693 divided by 100, that is 6.93 into 10 power minus 3. So this is wrong. Let's go to, this is option A related solution, and this is option B related solution, and I am moving on to option C related solution. At 50 second, the minus dx by dt is equal to K, how much we got? 6.93 into 10 power minus 3, alright, into 2 into concentration of x at this point of time is equal to 1, right, isn't it? Because the whole volume of the container is 1 liter. So this value is turning out to be how much? 13.86 into 10 to the power minus 3. So this option is also matching. At 100 second, dy by dt, like you can see that the expression clearly says that minus at 100 second, that means what? Over here, that at 100 seconds means 2 times the value of this, that another half of what you call this thing is consumed. So you will write that minus dy by dt is equal to 6.93 into 10 power minus 3 divided by 2. Another half amount will be consumed, right? So this value is some 3.46 into 10 to the power minus 3. Alright, so this value looks to be okay. So I guess this should also be the right answer, because you see, as time increased by another 100 seconds, like you could see that the concentration further decreases by half for a first order equation. Let's see the next question. A giving rise to 2b plus c. Alright, the total pressure in the beginning is P naught. So this is again related to the calculation part. So initial values are given. After some time, it is after total pressure is at a time t, this is t equal to 0, and after some time, let's assume some x pressure has gone from A. So 2x and x are the pressures of B and C formed respectively. Initially only A is present with concentration is A naught, okay, that's okay. T1 by 3 is the time required for the partial pressure of the A to reach 1/3 of its initial value, okay. The correct option for the given statement are first order equation, so rate constant and T half relationship can be found, isn't it? So we will see that rate constant and A naught, so this should be actually T half, so this is ruled out. This 3p naught thing we have to work out. You can see here that after t seconds at p naught minus x plus 2x plus x is equal to, you can see the final pressure is given as P1. So you got 2x equal to P1 minus P naught, so x equal to P1 minus P naught by 2. So when you write the expression for k equal to what? 2.303 by t log initial value is P naught by P naught minus x, P naught minus P1 minus P naught by 2. So you have to simplify this, isn't it? So you got this as 2.303 by t log 2p naught upon 2p naught plus p naught, that is 3p naught minus p1 equal to k. So you get it as like log of 3p naught, that is y parameter is log of 3p naught minus p1 equal to minus kt, alright, by 2.303 plus log of 2p naught. So this correlates with option A. You can see negative slope and positive intercept. And let's check this t 1/3, this is wrong, so this is also wrong. Let's check this. K equal to, for a first order equation, you can see it is mentioned as first order, 2.303 by t log initial concentration is given as A naught and time is 1/3. So final it becomes 1/3 of its initial value, right? So that becomes what? A naught by 3. Alright. So you can see from this that T1 by 3 is equal to 2.303 upon k log 3, isn't it? So the time required, T1 by 3 is the time required for the pressure. You can take anything, it doesn't matter, because anyways this factor is getting cancelled. Of A to reach 1/3 of initial value, the correct options are, right, they are behaving like ideal gases, log 3. So T1 by 3, and you have the A naught got cancelled, initial concentration. If A is present, concentration at A naught. So you got 2.303 by K, that is log 3. Log 3 is 0.4, that is equal to constant. So it is independent of concentration. So this B is also ruled out for this question. Right answer is option A. Okay. Let's check the next one. Like you can see the next, Sandeep. Like you can see in the next question that in a bimolecular reaction, when two molecules are reacting, apart from the regular factors which are related to the collision, the steric factor also comes into picture. The steric factor is like, steric hindrance, isn't it? This is steric repulsion, or we call it as steric hindrance, which is definitely an obstacle to the reaction to take place, right? So if this value is greater than 1, steric permitting the reaction to take place, steric factors are also there, but when p value is greater than 1, this is a hindrance to reaction, right? So what is happening is that if p is greater than 1, what will happen? The conditions are being asked. You can see the activation energy of the reaction is unaffected by the value of steric factor. That's true, because activation energy is purely intrinsic value. That means it depends upon the internal factors such as the internal motions of the gas molecules, internal kinetic energy, that is translational kinetic energy, etc., but not the external factors such as steric factor. So this activation energy is independent of steric factor is the correct statement, and experimentally determined value of frequency factor is higher than that of predicted value. Let's write that expression, right? That we know the normal form of the Arrhenius equation, but when the steric factor comes, this will come into picture. And left side values are experimental values, right side values are calculated values. Therefore, when I substitute here A experimental is equal to 4.5 times of A calculated into so on. Therefore, you can see clearly that experimental Arrhenius factor is greater than that of calculated Arrhenius factor. So this makes sense, isn't it? So when this B is making sense, D cannot make sense, because this is contrast to B. However, when P is equal to 4.5, the reaction will not proceed unless effective catalyst is used is wrong. I know that P value is very high. However, will not proceed is a wrong statement to consider, because it will proceed slowly if the P value is high, but will not proceed is not correct. So right answer for this question are A and B. Alright, so these are complicated questions related to the physical chemistry. You need to put a lot of efforts to understand the concepts. You need to practice a lot until you get the proficiency in this concept. So I wish you do that and learn the concept thoroughly. Okay, and I am sure that you are liking the videos. If you like the videos, please do not forget to press the like button. That will help me a lot in providing the good lectures for you. At the same time, share it to your friends. And also, if you are new to this session, please subscribe. I am going to post so many videos related to the JEE or NEET preparation in the coming days in an interesting manner. So please keep watching. That's it for today.